Hello everyone, this is Eric Engman. This video will be looking at how to calculate the volume which needs to be administered in scenarios involving injections. The formula will be the volume in milliliters equals the desired over the half times the volume. So the first example, a patient is prescribed an injection of 32 milligrams. It is available in an ampule containing 8 milligrams per ml. How many milliliters would you administer? So volume to be administered in milliliters will be desired over the half times the volume. So the desired amount is 32 milligrams. It's in milligrams. And what they have is also in milligrams. We must ensure that the units match up at all times. The volume 1 ml, the volume is 1 ml. So by substitution, we have 32 milligrams as the desired over 8 milligrams multiplied by the volume of 1 milliliter. The units will cancel out. 8 goes into 32 4 times. So 4 times 1 mil will be equal to 4 milliliters as the volume to be administered. The next question, the same thing. The desired amount is in milligrams, it's 72 milligrams. What they have is also in milligrams. Again, extremely important that the units match up at all times. The volume this time is 3 milliliters. So by substitution, the volume to be administered will be the desired 72 milligrams out of 12 milligrams multiplied by the volume of 3 milliliters. The units will cancel out. 12 goes into 72 6 times. So 6 multiplied by 3 milliliters will be 18 milliliters as the volume to be administered. The next question, the desired amount is 0.3 milligrams. It is in milligrams. What they have is 500 micrograms per 4 ml. The volume is 4 milliliters. At this moment, the units for the desired and the units for the half do not match up. So a unit conversion is required at this stage. So we can convert both into milligrams or both into micrograms. So the conversion is micrograms, milligrams. From micrograms to milligrams, we divide by 1000. So we can convert the micrograms into milligrams. So the 500 micrograms to be divided by 1000. It's a decimal point here. The point moves 3 times towards the left. So the 500 becomes 0.5, this time in milligrams. So what they have has been converted from 500 micrograms to 0.5 milligrams. What the patient requires or needs is still in milligrams, 0.3. So by substitution, the desired amount will be 0.3 milligrams out of the 0.5 also in milligrams multiplied by the volume of 4 milliliters. The units will cancel out. The 0.5 goes into the 0.3 0.6 times. So the volume to be administered will be 0.6 multiplied by 4 milliliters, which will give 2.4 milliliters. We can also convert the milligrams into micrograms and milligrams into micrograms. We multiply by 1000. So that 0.3 milligrams, if it were to be converted into micrograms, it becomes 0.3 multiplied by 1000. The decimal point will move 3 times towards the right. We insert the zeros. So the 0.3 milligrams becomes 300 micrograms. So by substitution, the volume to be administered in milliliters with the desired amount. The desired is now 300 micrograms. And then what they have is 500, also in micrograms. The units must always be the same, multiplied by a volume of 4 milliliters. The units will cancel out. The zeros will cancel out as well. 2 up, 2 down, and then 5 goes into the 3, 0.6. And 0.6 multiplied by 4 milliliters will give 2.4 milliliters. So the outcomes are the same. What matters is that the units always match up. The next question is almost identical to question 3, where what the patient needs is in milligrams and what they have is in micrograms. So there is a mismatch here. The units are not matching up. So we need to convert. So we can convert easily, again, the micrograms into milligrams. If we decide to convert micrograms to milligrams, then we divide the 200 micrograms by 1000. Or if we decide to convert the milligrams into micrograms, then we multiply the micrograms by 1000. So for example, if we decide to change the milligrams into micrograms, it becomes 0.3 milligrams multiplied by 1000. So the point will move 3 times to the right to 3. We insert the zeros. So the 0.3 milligrams becomes 300 micrograms. So by substitution, the desired will be 300 micrograms, rather, out of what they have, 200 micrograms as well. So the units are matching up, multiplied by the volume of 2 milliliters. The micrograms will cancel the micrograms, the zeros will cancel each other equally, and then 2 goes into 3, 1.5. So the volume to be administered will be 1.5 multiplied by 2 milliliters, and the outcome will be 3 milliliters. So again, important to ensure that the units match up at all times. The next question is what the patient needs will be 7.5 milligrams. It's in milligrams. What they have is 15, also in milligrams. The per mil means the volume will be 1 milliliter. So this is by direct substitution. So we substitute a desired amount as 7.5 milligrams. and then we divide it by what they have as 15 milligrams as well, multiplied by the volume of 1 milliliter. The units will cancel out, and then the 15 divides into the 7.5, 0.5 times. So the volume to be administered will be 0.5 multiplied by 1 milliliter, which will be equal to 0.5 milliliters. In question 6, the desired amount is 1,250 milligrams. What they have is 250 milligrams per 10 mil in 10 milliliters. So the volume will be equal to 10 milliliters. The units are identical, so a unit conversion would not be required. So the volume to be administered will be the desired amount, which is 1,250 milligrams divided by 250 also in milligrams multiplied by 10 milliliters, the volume. The milligrams will cancel the milligrams, 0 will cancel the 0. 25 goes into 125 5 times. So the volume to be administered will be 5 times 10 mil, which will give a volume of 50 milliliters. Thank you very much for watching this video. Follow the link and subscribe for more videos. Thank you.